The Elements of Non-Euclidean Geometry by D.M.Y. Sommerville. Chapter 2, Elementary Hyperbolic Geometry. Section 4, Properties of Parallelism. Parallel lines possess in common with Euclidean parallels the following properties. 1. The property of parallelism is maintained in the same sense throughout the whole length of the line. 2. Parallelism is reciprocal. 3. Parallelism is transitive. 1. The property of parallelism is maintained in the same sense throughout the whole length of the line. Property of transmissibility. Let AA' be parallel to BB', and let P be any point in AA'. We have to prove that within the angle BPA', every ray through P cuts BB', and no other ray through P cuts BB'. There are two cases to be considered according as P is on the side of A in the direction of parallelism or not. In the first case, draw any line PQ through P within the angle BPA', and on it take a point K. Then the line AK must cut BB' in some point L and BP in M. Hence, PQ, which cannot cut again either ML or BM, must cut the third side BL of the triangle BML, Pasch's axiom. But PA' does not cut BB', therefore PA' is parallel to BB'. In the second case, it is only necessary to take K on QP produced backwards. 2. Parallelism is reciprocal, i.e., if AA' is parallel to BB', then BB' is parallel to AA', figure 11. The bisectors of the angles BAA', ABB' meet in a point M. Since each meets the other parallel, draw perpendiculars MP, MQ, MR from M on AA', BB', and AB. By a comparison of the triangles, these perpendiculars are equal. Draw MM' bisecting the angle PMQ. Then if PQ is joined, PQ is perpendicular to MM' and makes equal angles with AA' and BB'. The lines AA', BB' are therefore symmetrical with respect to MM', and the reciprocity is therefore established. PQ are called corresponding points of the two parallels. 3. Parallelism is transitive, i.e., if AA' is parallel to BB' and BB' is parallel to CC', then AA' is parallel to CC'. There are two cases to be considered. A. Let BB' lie between AA' and CC', figure 12. We may suppose ABC to be collinear. Within the angle CAA', draw any line AP. Since AA' is parallel to BB', AP cuts BB' in a point Q. Then, since QB' is parallel to CC', PQ produced within the angle CQB' must cut CC'. Also, AA' itself does not cut CC'. Therefore, AA' is parallel to CC'. B. In the same figure, let AA' and BB' be parallel to CC'. Then any line within the angle CAA' must cut CC' and therefore BB'. Also, AA' itself cannot cut BB', for then we would have two intersecting straight lines AA' and BB', both parallel to CC' in the given sense. Therefore, AA' is parallel to BB'. Parallels in hyperbolic geometry are, however, sharply distinguished from Euclidean parallels by the following property. The distance between two parallels diminishes in the direction of parallelism and tends to 0. In the other directions, the distance increases and tends to infinity. Before we can prove this, we shall require several preliminary theorems. The Elements of Non-Euclidean Geometry. This book was written by D.M.Y. Sommerville, M.A. and Doctor of Science. It was published by the Open Court Publishing Company, London, G. Bell & Sons, Ltd. in 1919, and now is in the public domain. It is being read by Jim Renholt, with programming and illustrations by Jim Renholt in 2019. Thank you for listening.